All right, in this video we're going to talk about 9-4. So 9-4, there's two things in 9-4. First thing is called the zero product property, and the second one is solving quadratics by factoring. We learned how to factor in chapter 8, and in chapter 9 we also went over it. So today we're going to be solving those. All right, first thing I want you to do, look at the getting ready problem. Hey, it's a good good checkpoint to see how you're doing. Another SAT-like problem, or whenever you're mixing something with quadratics with some geometry in there, good chance it's going to be on the SAT. All right, so assuming you've paused it and given this one a try, it might take you a little while. It might take you 5 or 10 minutes to try this one. Let's go over it. So it says you're finishing a stained glass window hanging that your friend has started. You have enough supplies to add 6 feet squared to the hanging. You are planning to add the same amount of length to the length and the width. What will the dimensions be when you're finished? How do you know? Hey, so first of all, you know that the area that's already done, that I'm circling here in red, is 6 feet. And you're going to add 6 feet. So you already have 6 feet, and you're going to add 6 feet. So that's going to be a total of 12 feet. Okay, you also know that you're adding the same amount. So now, maybe I'll do this in yellow. So this is going to be 6 feet, and you're adding x right here. So this is 3 plus x, and you're adding x right here, so that's 2 plus x. And again, you know that the total is 12. So I can say x plus 2 times x plus 3 is going to equal 12. And the 12 is the 6 plus 6, the 6 that's already there and the 6 that you are going to add. Now you could mess around and try to solve this right here. You could just figure out what values of x would make this true. Okay, and the values of x that would make it true would be your solution. Okay, but we're going to solve it so it helps us a little bit with this section. So the first thing I'm going to do is I'm just going to use the box method here and multiply the length times width. So the length is 3 plus x, and the width is x plus 2. So if I multiply those together, I get x plus 2 times x plus 3. So it's going to be x squared, 2x, 3x, and 6. So I'll rewrite that now as x squared plus 5x. Remember, this 5x is coming from 3x and 2x there, so 5x plus 6. And then that equals 12. It's going to have an area of 12 square feet. Okay, and then what I might want to do there is to solve this, probably want to get all these things on the same side. So I'm going to shrink this up. So I'm going to subtract 12. And now I have x squared plus 5x minus 6. Don't want to do a slash there, slash here. Minus 6 equals 0. And then I can try to kind of refactor this side again. So I've got what multiplies to negative 6 and adds to 5. Well, that's going to be negative 6. So it's going to be negative 1 and a positive 6. So then I have x minus 1, and I have x plus 6. All right? Negative 6 times 1, or negative 1 times 6 is negative 6, and negative 1 plus 6 is 5. So I know that works there. And then I want to think about what the solutions are here. So I have x minus 1, and this is the zero product property, times x plus 6 equals 0. Well, what solutions make this true? Well, if I think about this, if I make one of these 0, and I multiply it by the other one, it's going to equal 0. So here the solution would be x equals 1. And here the solution would be x equals negative 6. So let's see why that works. If I plug in 1, 1 minus 1 is going to be 0. And when it doesn't matter what's going to be over here. This is 0 times anything. It ends up being 7, but it's still going to be 0. Okay, so 1 would work and negative 6 would work. But then I have to think about the context of the problem. I can't have a negative dimension. All right, so the negative number, a lot of times we got to just throw out that negative number. Even though it makes the statement true, it doesn't work in the context of the problem. So I have x equals 1 as the solution. All right, so if I go back up here to the drawing and I add a 1, so this is 3 plus 1, and then this is 2 plus 1. Now I know my dimensions. My dimensions are 3 by 4, and 3 times 4 is 12. Okay? So I could have also solved it from here. I could have figured this out maybe. Maybe x was 1, and 1 plus 2 and 1 plus 3 would make this true right here. Oops. So that would be equal to 12 if I plug that in. All right, so the zero product property states that when you have something that's factored, you have a binomial times a binomial. And if either of these are 0, okay, if this ends up being a 0 or this ends up being 0, the statement is going to equal 0 because you're multiplying 0 by the other binomial. Okay, so what are the solutions of 4t plus 1 and t minus 2? Well, if you're trying to find out when they equal 0, you can just individually set this one equal to 0. And you can set this one over here equal to 0 as well. So I'm just setting it equal to 0. If I want to find out when it's 0, it's an easy way to solve it. Okay, and then I can subtract 1, and I get 4t minus 1 equals, or 4t equals negative 1. Divide by 4, and on this part of the binomial, I get 4 t, the 4's cancel out, so I get t equals negative 1/4 is one of the solutions, one of the zeros. And over here, I just add 2. And I get t equals 2 on this solution. Okay, so these are both solutions. Let's go ahead and try, let's try a few of these. So go ahead and try all 4 of them. So pause the video, try these, and we'll see what you get. Okay, part A, it says x plus 1 times x minus 5. Well, what makes this true? Well, negative 1 would work here, and a 5 would work there. So the solutions could be x equals negative 1 or x equals positive 5. For part B, you got 2x plus 3 and x minus 4. I'll go up here with part B. So I can just say 2x plus 3 equals 0, and I can solve that. So subtract 3. So 2x equals negative 3, divide by 2. So x could be negative 1 and a half, negative 3 over 2. Okay. Or x could be equal to 4 if I plug in 4 right here. So x equals 4. So that would be the solution for B. Okay, part C. We've done A. Let me just erase that. Part C, we can set this one equal to 0. 2y plus 1 equals 0. Set this binomial equal to 0. And subtract 1 here. 2y equals negative 1. Divide by 2. So y equals negative 1/2. Subtract 14 here. So y equals negative 14. Okay, moving on to the last one, D. Same thing. Set this equal to 0. It's called the zero product property because you're setting it equal to 0. You're also finding the zeros. So 5n minus 4 equals 0. And add 2, and I get 7n equals 2. Divide by 7, and I get n equals 2/7. Okay, it doesn't always have to be x. It could be n, any variable. Khan Academy might say g of x or something. You just have to solve it the same way. So add 4. So 5n equals 4. Divide by 5. N equals 4 over 5 and 2 over 7. Okay, so that's the zero product property. Second part. we want to solve by factoring, kind of like what we did with the warm-up. So we have x squared plus 8x plus 15. So again, my a value would be 1, my b value is 8, and my c value is 15. So when I factor this, I have to see what multiplies to 15 and adds to 8. Well, that would be 3 and 5. 3 times 5 is 15, and 3 plus 5 is 8. So I know I can rewrite this, x squared plus 8x plus 15 equals 0. I can rewrite that as x plus 3 times x plus 5 equals 0. And if I solve this, well, we learned that this could be negative 3. So x could be negative 3, and this could be negative 5. So x could be negative 5. So my answers are negative 3 and negative 5, which is choice A. Okay. I want you to try A and B. So try those two. Make sure you're pausing the video. Give it a try on your own. That's going to help you before you start working on Khan Academy. All right, so let's look at A. I'm going to factor this. What multiplies to negative 14 adds to negative 5. That's going to be negative 7 and positive 2. So this is m minus 7, m plus 2 equals 0. Remember, these two things I'm highlighting in blue are equal. Okay, so one is just factored. This is the area model, and this is the length and the width. You can think of it like that. So I can solve this, and m would equal 7, and m would equal negative 2 for that one. Okay, part B. Factor it. What multiplies to negative 20 and adds to a positive 1? There's a 1 right there hanging in front of that b, hanging out in front of the p. So this is going to be 1. So this would be a negative 4 and a positive 5. So I factor that into p minus 4. P plus 5 equals 0. I use the zero product property, and I determine that p equals 4, or p could equal negative 5. Part C. Okay, I'm going to, we're going to talk about part C. Let's see here if there's another problem like this.